Hello everyone, and now we are going to start the next topic, that is combination of the spring. In the combination of the spring, we will see if the springs are in series and if the springs are in parallel, how can we calculate the spring constant? Okay, so this is basically about the spring constant if the spring are in series or in parallel. Okay, so first we will consider the spring which are in series. First is series. So if the spring are series, it would be like that. So there is the first spring which is having some stiffness, and there is another spring which is having some another stiffness. So consider that this is a spring which is having the stiffness S1 and this is stiffness S2, and there is a mass M block which is going to be attached here. So how can we calculate the system spring stiffness of the system? So it would be considered as 1 upon S. S is the stiffness of the whole system. Okay, so 1 upon S is equal to 1 upon S1 plus 1 upon S2. This is the formula. When the springs are in series, you can find out the spring stiffness or the spring constant for the whole system. Okay, so this is the formula for series. Now in case of second, when the springs are in parallel, like that, this is the first spring having some stiffness, this is another spring having some stiffness, and both are attached to the same block which is having mass M. Now the stiffness of the first spring is S1 and the stiffness for the second spring is S2. Now what would be the spring stiffness for whole the system? Because these are in parallel, you can see here, practically you can see here, when you compress this, that means when you move this block in the upward directions, both the spring will compress together. Okay, as you move this M block in the downward directions, both the spring will extend together. So that means there will be a compression and the extension for both the spring would be same, because both are compressing at the same time and at the same level, okay, to the certain level, and these are the springs which are in parallel to each other. So when you move this block in the downward actions, there will be extension in both the springs similarly, that means in the same amount, okay, because both will extend up to the certain limits. So there will be a same extension, same compression both the springs, so there will be a spring stiffness, that would be summation of stiffness for both the spring, that is S1 plus S2. Okay, this is for two springs. If there are more than two springs, you can like it as 1 upon S1 plus 1 upon S3, 1 upon S2 plus 1 upon S3, like that, and so on. We are considering two springs here, so that's why I have written like that. If there are a number of springs, you can consider that. Okay, and we all know that if I want to ask you what would be the omega n, then omega n for the system would be S by M. Now, for if in the examinations they will ask you find out the natural frequency, then you first have to calculate the stiffness for whole the system. Then you can put the value in this formula, omega n. You can get here from this formula. So basically, this is S1, S is equal to S1 plus S2 in case of parallel, because there is a equal deflection in both the springs. So that's why there will be an addition for both the spring constants. And there is another, you can say there is another position. You can say it would be also considered as a parallel case, when there is a spring here and there is a M block which is going to be placed between the springs. You can say there is also equal deflection. Why? Because when the M will move in the downward directions, so there will be a certain amount of compression in the lower spring, okay, and there will be a same amount of extension in the upper spring. Similarly, when the block M will move in the upward directions, there will be a compression in the upward spring or the upper springs, and the compression would be equal to the extension in the lower spring. The amount will be same. Okay, the deflection amount would be same. So that's why this is also considered as the parallel case when the springs are in parallel. Okay, so I hope you will able to understand what is the formula used in case of springs which are parallel to each other and the springs which are in a series. Okay, now the most important thing is that when the spring is going to be cut, so the next is cutting the spring. When you cut the spring, you cut the spring into two parts, three parts, and many times you can cut the in many parts you can cut the springs. So what would be the stiffness when the spring is going to be cut? Now let us understand. If this is a spring, okay, now I'm going to cut it into two pieces. Since I have cut this spring into two pieces, that means 1 and 1. This is completely one spring because we have cut it. Okay, so this would be 1 and this would be 1. If there is a spring stiffness as initially the total stiffness of the spring is considered as, and we have cut it into two pieces. So what would be the stiffness for the remaining springs, because it will be two springs again after cutting. So we have cut it into 1/1 ratio. Okay, so that would be 2s, and this would also be 2s. Okay, that means when you cut the spring into two equal parts, the stiffness of the spring would become twice. Okay, similarly, when you cut this spring into three parts like that, three equal parts, remember that I'm going to cut it into two equal parts, and this would be three equal parts, 1 1 1. Okay, so the spring stiffness would become three times for the three springs. Okay, like that you can solve the questions on the cutting of the spring. Okay, now see here, this is the simple concept because we have seen that we have cut the spring equally. Okay, now when we cut the spring which is not equal, now like that, that means we have cut this spring in m and n ratio. Okay, so that means here you can see there is a m and n ratio. I have cut this spring, that means not equally. Okay, so initially the spring stiffness is s. So what would be the final stiffness after cutting? So the upper spring stiffness would be m plus n upon m s. This would be the stiffness of this upper spring, and after cutting the spring stiffness for the spring stiffness of the lower spring, that would be m plus n upon n multiply s. So you can see this is the general formula. You must remember this in order to find out the stiffness of the after the cutting. This is the basically general formula. M plus n upon m, because the upper part is having m and the lower part is having n portion. So that's why m plus n upon m multiply s, and for the lower springs the stiffness would be m plus n by m multiply s. Okay, so this is the basically procedure. If you see in the above two cases, if you apply this formula you will get the same value. See, we have cut this into 1:1 ratio. Okay, so when you put this 1 and 1 in these equations, you will get 2s, and here you will get 2s. Okay, similarly when you put this value, you can get the value of 3s. Okay, so this is the general procedure how you can calculate when the spring is cut into two pieces. Similarly, when you, now here I'm going to put it numerical value. I'm just cutting the spring into 2:5 ratio. Okay, and the spring stiffness is s. So what would be the new spring constant for the spring separately? Because we have cut it, so there will be two springs. So for the above spring, the spring stiffness would be 7 by, the 7 means what? 5 plus 2. 7 by 2s, and for the lower spring the stiffness would be 7 by 5s. So this is the method for finding out the stiffness after cutting of spring. So I hope you will able to understand what is the stiffness for the whole system if the springs are in series or in parallel, and if there is a cutting operations of the spring, so how can you calculate the stiffness for springs separately? Okay, so this is the general procedure. We will do the numerical questions, so it would be easy to understand. However, I have given the numerical examples here, so it would be easy to understand. Okay,